Good evening, everyone. I'm so happy to see all these bamboo enthusiasts. It's very exciting. So on behalf of my colleagues at the Healthy Materials Lab and the Architectural League of New York, it is my great pleasure to welcome you tonight for an evening of bamboo. This is the bamboo edition of the From Field to Form series. I'm also here to welcome you to Parsons School of Design and the new school, whose mission is to lead inquiries into social and environmental justice as a basis for democracy. And I just have to say, this is a very good day in New York City for democracy. If I haven't met you before, my name is Johnsara Ruth. I'm co-founder. My colleague Allison Mears and I founded the Healthy Materials Lab here at Parsons 10 years ago, which is we just celebrated that 10-year anniversary, and many of my colleagues, our colleagues, are here tonight wearing a yellow dot, so you'll see Healthy Materials Lab represented. I'm a designer of healthier places and also a professor here at Parsons. Previous events in this Field to Form series, if you haven't been here, include materials, biomaterials like mycelium and cork and hemp and straw, geomaterials like earth and stone, and tonight bamboo will take front stage. And if you haven't already visited, over here on my right is a display of regenerative, healthier bamboo materials and some that aren't so healthy. And I'll talk about that in a second. But before that, a bit of housekeeping. The CEUs are available for tonight's event. I think there's a QR code in the back. Is that right? Yes. Oh, at the end. So you have to stay all the way to the end to get your credits. Also in the back are bathrooms. I think women's and men's here at the end. And there's a stair just in case we don't have electricity, like almost happened in Bali, Indonesia tonight. So a big note of gratitude to our donors who make this program and others like this possible. Tonight is supported in part by public funds from the New York City Department of Cultural Affairs in partnership with the City Council and by the New York State Council on the Arts with the support of the Office of the Governor and the New York State Legislature. Thank you, New York. Membership to the League makes this League's work possible. If you're not already a member, please become a member today. And also, on the back right, you could do that. This supports the array of programs and initiatives that deepen the culture of architecture and make it accessible to all. Thank you also to Friends of Healthier Materials that allow Healthy Materials Labs to continue to produce events like these. Please consider becoming a friend of Healthier Materials Lab too, and you can do that at healthymaterialslab.org. So at the lab, in our work, we strive to ensure that the materials used in all of our living spaces contribute to healthier environments. And this starts with material transparency, understanding every single ingredient that goes into a building product. And we assess each of these ingredients throughout their life cycle for human exposure and for ecosystems and climate, and that impact on all of these areas of our lives. The ideal scenario is when a material or an ingredient is regenerative, meaning it helps rejuvenate soils and ecosystems where it's sourced. Additionally, it should be safe and even beneficial to the people using it or exposed to it. So we all know that bamboo embodies many of these principles that we value. It's fast-growing, naturally strong. We're about to hear about all of its incredible properties. It restores degraded soils as it grows, and it can act as a natural fire stop. It can sequester up to 12 tons of CO2 per hectare, and we'll hear more. However, many bamboo products are composites, and they're not pure bamboo, and that they use adhesives. And so, for me personally, when I think of a bamboo product, bamboo flooring, or these products that we've been exposed to for many years, they contain adhesives that contain toxic additives like urea and phenyl formaldehyde or isocyanates, which are carcinogenic or asthmagenic, and linked to many different kinds of respiratory diseases. Fire resistance is often achieved with additives like boric acid. So this is what, in preparation for this event tonight, the Healthy Materials Lab team scoured sources for healthier bamboo products and spoke to many experts in the field. And so as you'll see in the material exhibition, few products actually made it onto the table. We have a lot of samples of bamboo that, thanks to our guests tonight, that are in its raw form, but very few bamboo products are there. And so there's a sign also on the box that says this very same thing, which is that bamboo is essentially hard to adhere to one another. And so it's been used to make durable structures for centuries without toxic adhesives, but in this century, we've added a lot of adhesives. And so on this table, you'll see this, this box that has many of those products that you might be familiar with that might have formaldehyde included in it. On the table, you also will see examples from our Parsons colleague, Kimberly Tate, who's working on builds of the community in her native Philippines, where they call bamboo bulan, or gold, a living treasure. There's a lot to learn from ancient indigenous practices about nature-based materials to advance innovation without the addition of unnecessary toxics and greenhouse gas emissions. And this is really important, and this is why Healthy Materials Lab is here, and I have been asked to give a shout out actually to an initiative that we have right now, which is a collaboration with Henning Larsen Architects and the Ramboll Foundation to accelerate global awareness. There's a QR code right here for a survey, and our team would really love it if you guys all lifted your phones, took an image of this QR code, and contributed to this survey. Anyone in the building industry can participate. So, for tonight's program, we pulled together people from across the globe and across bamboo ecosystems who are passionate and who have dedicated their lives to understand these challenges and potentials of bamboo and celebrating bamboo's flexibility, strength, and potential. We have a bamboo cultivator, a product and innovator, a designer, and an architect to explore how the future can be designed with bamboo. I'll give a brief introduction, but many of their longer bios can be found on our website. So Lucas Ocean is a regenerative agroforester and the founder and director of Regeneration Field Institute, located in coastal Ecuador. He oversees a 70-acre bamboo and agroforestry farm and develops sustainable supply chains for global bamboo technologies at BAMCOR. At 23, Lucas founded an eco-action education organization that created school garden programs in over 40 high schools. And there's more. Yep. Sorry. And those are in places like Nicaragua, Ecuador, California, linking food systems and education with science curriculum. He led community reforestation efforts that restored hundreds of acres of tropical dry forest in Ecuador using native trees cultivated in school and university greenhouses. Now he leads reforestation and environmental projects that promote regenerative practices in agriculture, construction, architecture, and education, and much more. So thank you for coming from Ecuador and from California. We're really grateful to have you here. Jonas Hauptmann is an inventor specializing in bamboo. He's the co-founder of the Biodesign Research Group and associate professor of industrial design at Virginia Tech. Jonas creates low-carbon building systems, including mass bamboo, which transforms whole bamboo culms into structural panels and beams through a process called lightly modified bamboo. Through international collaborations, he advances bamboo as a scalable material for affordable, climate-resilient housing worldwide. Thank you so much for coming. And Alora Hardy is a Canadian designer and founder of Ibuku, an award-winning architecture studio in Bali, Indonesia, pioneering initiative applications of bamboo as a primary building material. Since 2010, she and her team have designed over 200 structures globally, earning recognition from Architectural Digest and the Royal Society, and featured in publications, many publications like Vogue and Elle Decor and BBC and CNN and TED. Notably, their bamboo structure, you might have seen the art at Green School Bali, received the Supreme Award from the Institution for Structural Engineers in 2022. Elora is joining us today via Zoom tomorrow morning in Bali, Indonesia. And so we're so grateful for you waking up super early. I hope you have a lot of coffee. So you can read more about this. Joining me tonight for moderation and for a brief introduction is Paul Lewis, principal at LTL Architects, currently focusing their architecture firm on the architectural potentials of biogenic materials. Paul is a professor at Princeton University and former president of the president of the board of the Architectural League of New York, and co-author of the book Manual of Biogenic House Sections, which is really an inspiration for the collaboration between Healthy Materials Lab and Architecture League and this series tonight. So each panelist will give a brief introduction of their work, and then we'll all join for a conversation to explore more about bamboo. There will be time at the end for questions and answers, so we encourage you to, as those questions come up, to jot them down and join us in discussion at the end of this panel discussion. Thank you again for coming, and thanks to all of our panelists for joining in. Can't wait to hear more. And I'll leave it to Paul.
All right. In our past 6 Field to Forum events, which focus on specific materials, those with structural capacities have been somewhat limited to geogenic sources, earth and stone. And although these are great in compression, they have little tensile capacity, which is why bamboo and its extraordinary material characteristic seems to be an obvious biogenic option that we need to be talking about. It not only sequesters a large amount of carbon, which is diametrically opposite the high levels of carbon emissions associated with steel and concrete, but it also has the highest tensile strength to weight ratio of these 3 materials. And even in comparison to wood, it possesses double the compressive strength. But moreover, timber bamboo sequesters 5 to 6 times the carbon that softwood does per area of forest. And perhaps most importantly, it does it much faster, with the speed of growth to maturity and harvest many times quicker than wood. So in some respects, bamboo can be a rapidly renewable solution to the need to decarbonize now. And a critical aspect of this is that only a portion of the bamboo culms are harvested each year, leaving the forest largely intact. And it is precisely this ecological aspect, but also the challenges of growing and sustaining bamboo material supplies that Lucas Ocean will present in much more detail. Despite its material wonders, one of the challenges of bamboo is transforming it into a standardized building material. So to produce uniform, rectangular, engineered materials, only smaller slats can be extracted, as seen in this cross-sectional comparison with a tree, and there is significant material loss in the process. So very quickly, to extract the strats, the culm is split. At some point, it is cured in a bath of boric acid to mitigate the high levels of sugar in the fibers. The slats are sanded into more uniform shapes and then organized into larger surfaces or blocks. And these are actually then formed through a large amount of adhesives, which, as John Saar mentioned, frequently have toxicity problems. These units are then often placed under pressure and heat in order to make larger aggregations of bamboo. But the consequences of these processes can form impressive ranges of composite materials, from flooring to structural beams and columns to full panels, and even to complete structural building systems for low-rise housing, namely BAM cores, framing systems, which is shown here. In some ways, this presents a bit of a false binary between these highly processed engineering composites on the one hand and working with the non-standard calm on the other. Jonas Hauptmann, his material research and designs, in a sense, are innovative approaches precisely conceived to avoid this false binary. So, working with the whole calms and their inherent irregularities places an emphasis on how to assemble multiples into more predictable, measurable clusters, as exemplified in this house in Ecuador, where the diagonal bracing is, in a sense, a kind of generator of form, organization, and also circulation. In full calm construction, the joint is often the site of innovation. And needs, in a sense, the joint is what resolves the peculiarity of each calm. And this joint tectonic could be the subject of its own lengthy symposium. And for this and other bamboo attributes, there are 2 books, among others, that are excellent references. Hidalgo Lopez's Bamboo, Gift of the Gods, a fantastic title for a book, which we have an example of here, as well as Gernot Mink's Building with Bamboo. These are 2 recommended examples, books to look for examples. But given their relative straight geometry, it's no surprise that the calms are frequently used in linear assemblies, as here in Simon Velez's truss construction and the development of voluminous spaces through linear ruled surfaces. In another of his projects, the joint at the end of the calm is the site of much attention, with those connection details able to be self-similar by anchoring into the centroid of each calm. In contrast, Studio Cardones's housing prototype developed a complex prefabricated joint which clamps to the outside of the calms, allowing them to be more quickly assembled into a rectilinear cage. So with an approach distinctly different than these linear-based assemblies, we are extremely pleased that Laura Hardy is here to present her extraordinary work with Ibuku and Green School in Bali, predicated on a more expansive approach to the material form-making capacity of bamboo, both in terms of long-span complex curvatures of the calms, but also with robust and novel ways that bamboo can be utilized throughout the building components. So it is a great pleasure to have the expertise of Lucas, Jonas, and Alora here together. So please welcome Lucas Oshan to move us forward.
Hi, everybody. Big thank you to the organizers, Healthy Materials Lab, for having us here tonight. It's a pleasure to be here sharing about our passion and belief in bamboo. I'm here representing the Regeneration Field Institute and our nonprofit organization called Building Carbon. This is a picture of our education center at our farm, my mom at a build we did in the Amazon, and there's me and some Dendrocalamus asper in Brazil. My background, and I'm going to read from my notes a little bit, excuse me, I just want to cover, there's a lot of material to cover in a short time. So, in my early career, I worked scaling up a nonprofit organization that worked with university and high school students. And in a lot of the work that we did, students asked us the question, this is great to do as a volunteer activity, whether it was regenerative farming or gardening, but how do we do this as a career? And a lot of times I was hard-pressed exactly how to answer that question, that young people feel motivated to engage in regenerative careers, but it's not always an easy career path in terms of how to enter into that. And so with the development of the Regeneration Field Institute, that's the question that we seek to answer, is to try to inform and illuminate some career pathways towards regenerative careers and industries. The coastal region where we worked in Ecuador was hit by a 7.8 magnitude earthquake in 2016, decimating a lot of the high schools that we worked at. The houses of the director of our program actually was destroyed, and of many friends also. So I traveled down to lend a hand in a disaster relief effort, and my now wife and I were just starting dating at that time, Raisa. We started a project to build shelters for the people that were displaced from their homes. That project eventually grew into an initiative that was supported mostly by private sector from within Ecuador to build 70 shelters and then these disaster relief houses you can see some of the models of here in this picture. I want to give a big thank you to Robinson Vega, who is our teacher and mentor, the really talented Ecuadorian architect who sort of showed us the way in terms of design and how to teach others about how to build with bamboo. During this process, we came to believe deeply in the regenerative industry potential of bamboo and of regenerative agroforestry, and we founded the Regeneration Field Institute towards the end of that disaster relief process. It's an agroforestry and bamboo growing building lab on 70 acres of land. It's our farm campus where we host our education programs. We'd be pleased to host professionals seeking continuing educational opportunities or students from Parsons or any other education institutions in hands-on building work down there. So welcome. For the past 6 years, I've worked across bamboo and timber supply chains, developing my experience in harvesting, logistics, and processing operations. I began through the disaster relief projects that we did, but then I started in 2019 as director of supply chain operations for a company called Resource Fiber, and then later for Bamcor, which I worked at as in the capacity of supply chain director up until just about 3 months ago. And I can get into a little bit more about those companies and some of their successes and failures in the question and answer period if people are interested to learn more. Since 2022, I've been a close collaborator also with Jonas, developing our MassBoo system that he has developed at Virginia Tech, and I know that you'll enjoy a lot hearing from him about that in more detail next. Currently, I'm scaling up a new regenerative agroforestry farmer field school that will launch in early 2026 to involve 150 farmers in coastal Ecuador. My view on bamboo, after a number of years now of sourcing, building, growing, and teaching about it, is that bamboo is incredibly strong, lightweight, grows fast, it's abundantly available, and renewable. I envision bamboo regenerating tropical landscapes, covering the valleys and hills that are degraded, creating jobs, restoring ecosystems, sequestering carbon, and reducing the footprint of construction by displacing environmentally degrading materials from the supply chains. But bamboo building is still not cost, performance, or design competitive for mass market applications. Not because it can't be, but because the sufficient innovation and investment in product development hasn't happened yet. Wood, for example, has a couple 100-year head start on it in terms of industrialization. We think MassBoo can crack that code, though. See a quick view on the global context of bamboo land cover and industry with a few country examples. There's an estimated 30 to 50 million hectares of bamboo globally and about 1,600 species. For reference, a standard Midtown Manhattan block from the middle of the street on one side to the middle of the street on the other side, square, is about 1 hectare. In China, there are an estimated 6 to 7 millions of managed bamboo and about 10 to 30 million people estimated to be working in the bamboo sector. People say it represents as much as $60 billion in annual sales there. People there working in that industry harvest and manufacture everything ranging from biofuels to flooring to textiles to toilet paper and many other products. In Jamaica, the government reports that there are 50,000 hectares of Bambusa vulgaris, a species planted during British colonial times, yet despite several large-scale attempts and initiatives to raise funds, there still remains no significant industrial demand. In Ecuador, we have an estimated 250,000 hectares of naturally occurring bamboo, mostly a species called Guadua angustifolia, and another 2,500 roughly of bamboo in plantations that were intended for a flooring industry that never came to pass. In the Philippines and Vietnam, India and Indonesia, among other places, there are growing bamboo sectors that you can see kind of throughout this bamboo belt across the center of the globe. Ecologically speaking, bamboo is a pioneer species. It grows along riverbanks, in ravines, in valleys, on slopes, and in areas that have experienced disturbances. Its rapid growth rate and establishment mean that it can capture carbon quickly. Its roots, its leaves, its branches, and all the organic matter that it rapidly produces contributes towards the rebuilding of soil carbon and soil health. The spreading of the rhizomes through the soil help to stabilize slopes, mitigate erosion, help create more infiltration of water into the landscape, and this groundwater storage also is achieved through the swelling of the roots that some call a bioaquifer. I think that's a term coined by Arif Rabik from his book Towards Resilient Bamboo Agroforestry, which is a great source of information about growing bamboo. Bamboo ultimately is a deforestation-free, fast-growing structural material that can be continuously harvested from the same groves without dismantling the whole ecosystem where the bamboo comes from. Here are some endangered howler monkeys. My daughter admiring them. Growing in some bamboo that's just below our house at our farm. And this was a degraded pasture 7 years ago that monkeys would not have dared try to pass through for fear of jaguars, which aren't there anymore, but ocelots and other things, dogs even, that might prey on them. And so it's rewarding for us to see that happening. And this is actually an area on our farm where we do harvest and utilize bamboo from, but because you select just the mature poles, the ecosystem stays intact and is available as a biocorridor for the monkeys. Here's a view of part of our farm campus. The orange you can see in the hills in the background is naturally occurring guadua. I can't really make it out, but those are stands of guadua across the hillside. And in the middle, there's a strip along the Chagwalu River, which is a river that passes by our farm that has bamboo bordering on either side of it. Outlined in red in the foreground is bamboo that we have planted on degraded slopes, in ravines, and that is beginning to form a biocorridor connecting the forest of our neighbor's farm to other riparian zones on the other side of our farm. And this is an area that we're also actively managing and taking bamboo from for our construction projects. In Latin America and specifically in Ecuador, I'm going to start focusing more on this region. And Guadua angustifolia is the main species that we have in this region. It originates from the Andean lowlands on both the east and west sides of the Andes. There's a lot of other species of guadua and of bamboo throughout the Amazon, but they're mostly a little bit smaller. So the main structural species we work with is Guadua angustifolia. And there's vast natural stands of that in Ecuador and Colombia both, and a very long history of its use for everything ranging from handicrafts to wall systems. And so the stick frame construction you see these days is somewhat modern, thanks to some of the treatment methodologies, but people have been using bamboo for thousands of years. How bamboo grows, there's both clumping and running species of bamboo, and so you can kind of see in these cartoons that the running species tend to spread out with the rhizomes growing sometimes a long distance underground and then sending up new shoots. The clumping varieties stay in a tighter sort of cluster or clump, sending out new shoots from rhizomes that stay much closer together. The rhizomes are sort of underground branches, and then off the bottom of the rhizomes is where the roots grow from. Moso bamboo, which is the main industrial species in China, is a running species, and so you can see, kind of make out the difference of how that's just sort of evenly spread throughout the whole forest, whereas especially like the guadua, you can see it's a big clump, and Dendrocalamus asperi can make out the individual different plants. After the rhizome networks develop, each year there's a shooting season where new shoots rapidly grow, sometimes in as little as 6 months up to full height, which can be 100+ feet. And they get up to that canopy layer before they bother to make any branches or leaves, because that's where the photosynthesis happens. And so, evolutionary, biologically speaking, it behooves them to get up to where the light is before they branch and leaf out. Many claims are made about how quickly bamboo can be harvested after planting. The truth is, it is heavily dependent on the site conditions. So the fertility of the soil, people claim bamboo is so great to grow in degraded soils, and it's true, it can survive in degraded soils, but the time horizon from planting until harvesting is going to be a lot more delayed in the case of a really degraded site. Most bamboo species develop and expand their rhizome networks within about 3 to 8 years, with the growing canopy supplying the energy that results in thicker shoots each year. So the bamboo doesn't get thicker as it grows. It emerges from the ground at the diameter that will always be. What happens is that over time, it gets more and more dense. With Guadua, we anticipate the first significant harvest of construction-grade bamboo in the sort of 7 to 10-year time range. Our Guadua harvesting practice is that we remove about half of the mature culms each year, retaining enough for strong photosynthesis in the canopy layer, and then also so that the grove maintains a sort of architecture of branches for the bamboo to support each other, because if you create empty spaces in the grove, the bamboo tend to sort of flop over and bend a lot more into the empty spaces, which is not the best for construction. Yields from 1 hectare can be around 1,000 culms per hectare for a really well-managed stand, and that can represent around 20 to 30 tons of dry biomass per year, or the equivalent of up to 40 to 55 tons of CO2 per year. So there's a lot of different ways to do this accounting. It depends on what the use of the bamboo is, and so that's why you see like a big range of numbers. But a lot of it depends on how the material that is extracted is then utilized. If it's a stable source in the built environment that's a long, durable carbon storage, or if it's just being harvested and laid on the ground, it's a big difference. A thinning harvest of smaller diameter bamboo in the 3 to 5 year range helps also, as does regular weed control and fertilization. Again, depending heavily on the site conditions that you start with. So yeah, it thrives in really well-draining soils, but it is adaptable. So it can grow in other soils. It can sort of forge its way into a more healthy rhizosphere as it expands out its root and rhizome networks. But that'll be a slower process if you're starting out with more adverse conditions. It requires around 1,200 millimeters, or around 50 inches of rain spread throughout at least 7 months of the year. You can stretch its range and grow it in different types of conditions, but it's going to perform more poorly. Yep. In terms of post-harvest processing, the types of post-harvest processing depend heavily on the end use as well. And so if you're going to be using it for temporary uses, you can basically use it right after harvesting. You can use it for scaffolding, for bracing in concrete construction, for agricultural tutors, and no drying or really treatment is necessary for those types of uses. For permanent applications, a borate or thermal treatment is necessary for like what Paul was talking about to help protect it from pest or fungal attacks. So boric acid and borax is the sort of global standard for treating round culm bamboo, especially for permanent construction applications, and that makes it resistant to pests and fungus primarily. You have to perforate the bamboo long ways through the nodes with a sharpened rebar. It's a difficult process requiring a fair amount of strength and persistence, and then you clean off the bamboo on the outside, usually with a pressure washer if you have one, and then submerge it in this tank of these chemicals for about 5 days, take it out, drain it out, and then next comes drying, where you put it into these stacks where it can drip out the remaining chemical and water out of it, and then also dry in the sun. How long it takes depends on how sunny it is and how hot it is, but you sort of rotate the bamboo and turn them as you go to get an even dry on all sides, keeping it separated from the ground. After they're dry, then you want to store it somewhere out of direct UV contact and away from moisture to be able to then have them in a stable state ready for construction. Even a short presentation talking about bamboo supply chains and industry wouldn't be complete without at least briefly mentioning slats. So slats are the primary industrial format for bamboo globally. They're made by splitting the bamboo, denoding it, planing it, treating it, and then drying it usually in a kiln down to something like 12% moisture content. In China, borate treatment has largely been replaced with like autoclave carbonization process. And then you get something like this kind of products made out of slats. There is a very low yield recovery from this process in terms of all of the fiber growing in each bamboo. As little as 20% or less of the fiber from a given bamboo makes its way into a product like this. And so that means that it is expensive and inefficient, and in some ways, not the most elegant application, because you're sort of turning bamboo into something more similar to wood than keeping it as bamboo with its original super high performance morphology. But slats are really strong, versatile, and they're easy to ship because a lot of fiber fits into one container, and so for shipping around the world, it makes sense as to why that has persisted. Jonas will touch on that some more in his presentation also and compare it with what we're doing with Masbu. In terms of current demand in Ecuador and Latin America in general, in Ecuador, there's estimated to be about 200,000 people currently engaged in the bamboo industry, not necessarily full-time work, but that are harvesting, transporting, managing stands. There's around 6 to 8 million poles per year that are exported from bamboo to Peru. That's seriously underreported. I think they say it's around like 2 or 3, but we have some friends that have done surveys and it's much, much higher than that. 30 million plus tutors are used for the banana industry, so rainforest certified and organic certified banana plantations can't use plastic, and so they use like the top skinny part of the bamboo. It's about 4 meters to prop up the bamboo so they don't fall over with the big heavy racks of bamboo on them, or of bananas on them. They're used for bracing and scaffolding, and for the stick frame construction market is still relatively small, but growing in terms of like eco lodges in the Amazon or rustic beach touristic accommodations on the coast and stuff like that. Social housing also is expanding in terms of the use of bamboo. The Ministry of Urban Housing and Development had a big project a couple of years ago where they made trusses and roof structures of a fair number of houses, like 500,000 houses or something, using bamboo. We've built a bunch of different houses and community infrastructure, and there's an awesome organization called Caemba that does a very low cost and elegant, like $2,500, I think, house for really vulnerable populations in Ecuador, made out of a Dendrocalamus asper. Slats, historically, there's a fair amount of slats being exported from Ecuador. I think Bamcor, we exported somewhere around like 60, 70, 80 containers from Ecuador over the years. And then there's some Colombian companies that contemporarily also are exporting bamboo because the laws in Colombia are a little more difficult in terms of harvesting and setting up supply chains. In Colombia, Mexico, Peru, Guatemala, Nicaragua, and Brazil, there are also significant scale bamboo projects, but with comparatively low demand, even to the relatively small demand that exists today in Ecuador. So given bamboo's rapid growth, strength, and ecological and carbon benefits, why is it not being used more widely? From my perspective, the key barrier is insufficient research and development and investment. For bamboo to break through into the construction mainstream, we need to involve more designers, investors, engineers. The farmers are ready, I think. We have enough bamboo and we can get it. To advance bamboo innovations, we need to improve cost, performance, and design. And prefab systems like Masbu significantly address all three of these barriers. With better products, we can generate more demand. With more demand, we can unlock a global regenerative industry. Naturally occurring bamboo can satisfy a significant level of initial demand, but as demand grows, so will interest in establishing large-scale plantations to lower costs and improve logistics. With the establishment of these new plantings de-risked, we can work to regenerate the degraded tropics, sequester billions of tons of carbon, and create a lot of meaningful employment. So thank you very much for your attention. Appreciate it.
Thank you to the organizers and all of you for being here tonight. I'm really excited to talk to you about how bamboo might scale. So bamboo already makes beautiful houses, for single families, beautiful public structures. But the question is, how can it really impact housing around the world? We need something like 96,000 new houses a day just to make up the backlog, and that's not happening today. We hope that bamboo might be one of the answers to that. This is just a rendering of a concept for multifamily housing in Ecuador using our bamboo system. I wanted to acknowledge not only the organizers tonight, but also some of our sponsors, including the AIA, ICAT, INBAR, Base Baha'i Foundation, and Regeneration Field Institute, who has been a key partner in developing a lot of what you'll see tonight. Also, James Wolfe, a bike maker, industrial designer, and now friend. The image in the middle here where we've turned a bamboo cane into a four-sided object once and failed the second time. I left Vietnam on my first trip to learn about bamboo as an optimist, thinking, oh yeah, we can make it into a 4x4. It turns out only half the time at half the length. So that's really where we started, and I'll show you some more as we go. Tonight I'm going to talk about what I consider the crisis, about materiality, about the boo spectrum, about mass boo, and about scaling the work that we're doing. So you've seen this in the past, probably two presenters, but I want to point out where the housing is needed and where the bamboo grows. They're the same place. And this is why bamboo is maybe going to enter its golden age. In other words, if we use trees, if we use cement, if we use steel, we see problems with all three. Even with lumber, most of these countries have mostly tropical hardwood. We need those trees to be the lungs of the planet. We also need them, we need the resources quicker. So if you think about the speed at which bamboo grows, this 5 to 8 years, 8 years for the first harvest, this is a key difference. In my mind, all these materials come from the biosphere. They all have some natural quality, but can we get them in a healthy way, in a regenerative way in time? And the answer is with any of them except for bamboo in the tropics, the answer is no. So bamboo is also interesting as a craftsman and an industrial designer because it's this material that is both regular, it looks like a line, maybe a hand-drawn line, not an architectural drawn line, but it also is incredibly irregular. And that set of differences relative to a material like a tree branch makes bamboo something that we maybe can harness in a regular way. So the question is, how do you unitize bamboo? How do you accept that it cracks, that it has nodes, and that it wanders, but at the same time, respect that morphology, but harness it to be something more, and more mainstream. So we do that first by analyzing bamboo through, very, very kind of hands-on means, through technology means, and in the end, we try to understand the material and its morphology more intimately so we can leverage more of its properties in a complementary way to its original morphology. So also I would say that there's what I would call a range of bamboo that on the one hand you've heard about engineered bamboo made from slats. On the other hand, the process that was historically called bahareke, very similar to wattle and daub, originally with wood frames. Over the last 100 years, more and more bamboo frames, especially since treatment was developed. These two areas of research are actually somewhat mature, but they still leave this giant hole, which is how do you get from a single-story house or from a highly engineered material to something that can be made with local labor and local resources, but at a scale to house the 96,000 families a year that need new houses, or day, sorry. So for me, this is the binary. On the one hand, bamboo canes. On the other hand, these composites that we've already heard use lots of glues, sometimes very toxic glues. We've also heard they make lots of waste. But really, until now, we haven't had much discussion within the community of bamboo development about what to do in between these things. So I would call that the bamboo spectrum, the space between these two extremes, the space that may have been seen as tiny, but in fact is infinitely large if you really get in between these two things. So that's the space that we're trying to occupy, or at least clue the rest of the world to thinking about, the space between engineered bamboo and bamboo engineering. So that starts with the kind of DNA of a system, and that system is to say, can bamboo be made somehow flat with morphology intact? On the left is what we call lightly modified bamboo that has parallel faces, and on the right is also lightly modified bamboo, but with tapered faces. If you imagine the tapered bamboo following the natural original morphology, if you cut a cross-section, it's going to be parallel. But as you move down that line, eventually, if you came to the end, you would hit two edges meeting. We never get that far. We can only go 4 to 6 meters, but that's the intention. And what's pretty interesting about this is that we actually gain strength and stiffness by doing this. So you could say that we're actually losing some. If I compared two 11-centimeter bamboos, like what would have been on the left-hand side of the left-hand image, before they were cut, we definitely lost something. But if you compare it to a 9-centimeter bamboo, now that we've made the left one and cut to 9 centimeters, we actually gained roughly 20% stiffness and 20% strength. Also, if you compare on the right-hand side of the slide, what happens in reality when you make a slat? Well, if you had a 100-foot tall bamboo, you lose the first meter because it's too squirrely to work with. Then you take 6 meters of usable material, and then everything above that also doesn't get used to make slats, at least not industrial slats. On the other hand, with the LMB concept, we can take 4 even cuts, and we can turn all of them into things that have parallel faces at the length of 3, 4, 6 meters. So the difference in recovery is tremendous. So, what we do with that is we turn it into composite panels, what we call MASBU. On the left is an experimental structure made by students from VT, looking at different ways to connect the panels, trying to think about how to get away from the edge to where the material has some real strength. On the right is an example of a MASBU panel using slats that have only been planed on one side and a core of Guadua augustifolia, Colombian bamboo. To look at that a little bit closer, you'll see on the right-hand side of the slide, a core layer running the long way through the panel, morphologically intact, then a lathin layer that can be at 90 degrees or at opposing 45 degrees, and then with a mineral or cementitious coating on the inside and outside for fire, sun, water, and insects. So we see this as the kind of basic DNA of the panel part of the system, and I'll talk about the beams in a minute. On the left, you'll see lots of single panel experiments. I work a lot with engineers, material scientists, also with architects, and the scientists and engineers would say, oh, you got to make a lot of one thing to figure out what works. What we did was look at the middle of the problem. We didn't look at LMB first. We didn't look at one single panel. We just went for it and made a bunch of single tests to figure out, in a really basic sense, what might work. And what we came to was that running bamboo the long way through the middle was the easiest and most sensible approach. It's not really a whole lot like CLT. When we started, we thought it would be. In hindsight, we were wrong. It's also not exactly like the Bahareki or CBFT system, and that's because we're getting composite action in the bamboo layers. The traditional method gets composite action in the cement shear part of the system. So in the beams, we take 2 bamboos and we basically flip them so that we have a fat end and a skinny end together. And that gives us a really, really small amount of waste because we're only, staying parallel to each of the 2 outside cords. You can see, depending on the species, you might have more or less fall off. And we're trying to get to a point that we have roughly, if you look at the kind of diameter, 1/3 or slightly more than 1/3 of the width as a flat spot. We made up this number. We've never really explored what it would be to have less or more, but it turns out to seem to work pretty well. And you'll notice that as the species get more and more solid, that you have much less relative fall off. We also think that to make bamboo really scale, we have to have some strategies that use, frankly, technology. And that's because bamboo has eccentricities. If you want to use it to its fullest potential, you have to think about where in the building each member might go. That doesn't work with an industrial mindset. It's a post-industrial mindset. And so we're thinking within the panel, are there core elements that are the thickest and the woodiest and the stiffest? Are there other elements that are just fill? Or depending on where in the building you're going, do you have thicker or thinner bamboo? And so these images are to represent that notion. We've done very little of this technical work at this point, but I think as we have more proof that it works, that will be the next step as to how to really continue to raise the efficiency. Because this, as Lucas says, is the biggest problem. Is if bamboo is wasted, or has bamboo co-products, the high value material doesn't make it into the building. If it doesn't make it into the building, bamboo costs more. So bamboo's biggest barrier is cost. So just to talk a little bit about the testing we do have so far. So we've made panels 2 feet by 6 feet by 5 inches thick. To make them bend in 3-point bending, we apply loads of between 6,000 and 12,000 pounds. That's when they break. And if you equate that to a floor section, residential floor, we can get to about 4 meters with a 1/2 inch of deflection, which is an allowable load for a Western floor. And so we on the floors, we think we have a pretty good sense. We're still working on how to do that out of other species. The Guadua panels from Ecuador or Colombia, they break at about 8,000 pounds. The Vietnamese ones at 12,000 pounds. So we've also made some beam tests, and those we haven't done in a lab yet, just on a university campus, on a tennis court, under a tent using sandbags. But what's pretty remarkable is that we reduce the depth of the section by 10%, but we wind up 1.65 times stiffer. We also reduce the cost for hardware significantly. So the beams seem to be a really promising potential. And we can make them with very simple tools, literally a hand planer and a jig. So also, so far I've been talking about it as a bamboo system, but for a minute I'd like you to change your frame of reference and think that actually it's a bamboo fortified masonry system. And that's because the truth is that most of the world wants a material to, pass the kind of kick test. When you bang on something, does it sound really, tinny and hollow or really solid? And so, although we'd love to challenge the cultural expectation that we should think about, temporal buildings, we also accept that that's not really what the world is asking for. And so we're really working to figure out, how much mineral, how much cement, how much, toxic glue do we need in order to make this balance? But we really think that, these panels, we're not making them out of romance. We see them as beautiful, but we really see their utility being the most important quality. We've also been thinking about the connection system. So if you think about, on the one hand, a CLT panel, it's big and solid, and you can kind of connect it any way that you want. Of course, there's physics and engineering involved, but it's really easy to connect to because it's solid. But bamboo is more like IKEA furniture. It's more like particle board. It's porous, right? So how do you connect to particle board? You don't use the edge. You move inward with connections that have more surface area. So using, EMT conduit as a dowel pin or wood blocking as a member to pick up a screw, moving the connections one cane away from the edge so you have a full round enclosed element is what we've been exploring until now. So in the end, what we're hoping to do is to get to kind of mid-rise, 2 to 5 stories, using bamboo panels and bamboo beams to make up all of the kind of structural system. Of course, there'll be some metal connections. If this all works, it's going to take accessible technologies. It's going to take, continue to be very democratized. In the beginning, we, literally bring, maybe a motor in a suitcase and build everything else in the Philippines or in Ecuador where we've been working. Eventually, though, as we kind of move to a lightly industrialized phase of the project, we really want to imagine that, we're going to need skilled labor. We're going to need machines that use some degree of automation, IoT technologies, machines that will move in and out to recognize the bamboo's thickness. This is how we're going to get to this higher rate of efficiency. But we want to do this in a town-by-town basis, not with mega factories, but with micro factories. So this is a big speculation, thanks to AI for the help and with lots of papers that were, entered in. But basically, the potential for bamboo housing to sequester carbon, to be significantly, carbon storing, is really, I believe, a real potential. And if you think about it from a development perspective of housing, let's just say a good margin is 15%. Well, if you can get 1% more of margin by selling carbon credits, maybe this will be a meaningful way to help unlock housing. Thank you.
It's really nice to be here. I lived in New York for many years, and I could imagine being with you all there, but joining you from Bali today. And I grew up here in Bali. When I was 9 years old, my mom, she asked me what I would want my very own house to look like. And so I drew this fairy mushroom, and then she actually built it. I don't think I realized at the time that this was so unusual, and maybe I still haven't, because I'm still designing houses and still designing them with bamboo. This one would have been back in 1990. And it took some time to connect the dots, but this is a 6-story home that I built in Bali in around 12 years ago now. It's built entirely from bamboo. It's called Sharma Springs, and the living room overlooks the valley from the 4th floor. You enter this house by a bridge, just because that's what the land called for. That's what the site needed. And it can get hot in the tropics. So to make these big, curvy, overhanging roofs, they both catch the breezes and protect the bamboo structure from UV and from rain. But many of the rooms do have these tall windows, also made out of very carefully crafted bamboo elements. This is all very artisanal work in this house. That keeps the air conditioning in, keeps the bugs out. And some rooms we leave open, the parts that we need to. I once had a client in the very early days who wanted And so boxing off an area with walls and a ceiling just didn't feel right. So instead, we built this giant bamboo pod, wove a basket essentially to create that space. So we've always been looking at ways that we can bend and weave the material and the landscape together. Of course, we do have all the practical things, all the necessary luxuries like bathrooms. This one is a basket. It's in the corner of the living room. And I have to tell you, some people do hesitate to use it. We hadn't quite figured out incorporate acoustic insulation at this time. And so there are lots of things that we've been working on over the years and some things that we've given up on. We don't really recommend hand making toilet seats or toilet tank covers anymore, but this is certainly a photo to have in our repertoire of crazy things we've worked on in conversation with this incredible plant. One thing that I have learned is that bamboo, it will treat you well if you use it right. And because it's a new frontier, that means that we've had to understand bamboo to really get into it, to listen for how to work with it. Here we are testing arches in parallel to the construction of the Arc at Green School Bali, which was built in 2021. And this was just a leap into the future of possibility, not just in our own little bamboo bubble in Bali or in the world's connected network of bamboo people, but it inspired even those who thought that they weren't interested in bamboo or natural material in particular. The engineering prize that it won wasn't in a category of sustainability or bamboo or wood. It was simply the supreme prize of the year. And that meant a lot to me that it could, that what we've learned from this material could translate and make a difference and connect in with the broader world of what's going on with construction and engineering and industry. Inside this building, I think people love it because it actually feels more like a body than a building. It has a familiarity to it. And so I'm only in this world of architecture and because of bamboo and because of my family. My mother took the stand that we should be a family in Bali from the 1980s. And my father and stepmother decided to build a school, which made absolutely no sense to me. They were in the jewelry business. But once I saw it, I understood. They chose bamboo to build this campus that they called the Green School. They needed a material that was fundamentally green, not just a little better, not just recycled or reclaimed, but actually showing a path for the future. This material, this building is a promise to the kids. This is a sustainable material that they won't run out of. And it's just, as a thought, it made perfect sense to me. Why haven't we been designing things with these criteria in mind? As you know from everything you've learned about bamboo today and perhaps before, it is beyond just being eco. It's beyond being a little bit less bad than something else. It embodies goodness in a way that we should really stand for and evaluate everything against. I just wondered when I saw this building 15 years ago, why hadn't this already happened sooner? There's bamboo all around us in Bali. And what can we do with it next? Also, the philosophy that it's led us to is to be light on the land. I am still mesmerized by the simple beauty of this construction site. These foundation points, what was this, 2005 or 2006? I still haven't achieved as pristine a construction site as this or as Project A Light on the Land as they admit. It's this world originated with my dad and his ideas for Green School Bali. And when I joined in 2014, I thought I was coming to help out. It turned out I was founding Ibuku. We are a team of architects, designers, and builders working together with Bamboo Pure, the builders, which is our artisan construction workshop. And what we've really done together is to create a new way of building. And over those past 15 years, we have built over 200 unique structures. Some of my favorite ones are here at Bamboo Inda, this beautiful valley here. You see them snuggled into the landscape. Please come visit us. You could jump into those pools or stay in our newest guest room, which is called New Moon. You can jump right out of the window and into a completely natural spring-fed plunge pool. It's one of my favorite places in the world. Another house we did there was a replica of a traditional Sumbanese home. This house looks really like what a Sumbunese traditional house looks like, with the exception of those primary columns would have traditionally been wood. They would have made them out of wood, and that's no longer the case because they don't have much wood to go around to build their houses with. So they are switching to steel in most cases. But the bamboo elements of this house were protected to a large extent by the wood smoke from the fireplace in the center of the house, even though they did not have boron or any other treatment solutions for the bamboo at that time. So at Bambooinda, we've also just added a new riverside restaurant. Here's an example of a sketch that within a year can turn into a building nestled among the rice fields. There were existing rice fields on the site, and we took a stand that we would not build on them. We just built on the edges where there used to be a cowshed. And while you're in Bali, you can also visit the Green School and see that we keep building new classrooms each year. This is a makerspace that will open in 2026. And with each step, we find opportunities and excuses to create new conversations with the material and to incorporate others. We continued innovating the systems that you saw in the ARC at Green School to create a yoga shala in Ubud. Come and do some yoga here. We featured this grid shell in an entirely different way and got to push the limits a bit farther than I could in the ARC and play with them once we had some of that engineering data in place. And if you find your way to Malaysia, there are some of the strongest typhoons in the world there. So when asked to create a big bamboo building, we considered what parts are bamboo actually really ready for and good at this time in this place, while achieving a form that feels wonderful to people. So we combined actually an elegant steel spine in the middle of this building so that it could withstand those typhoons, and also so it could provide a sense of reassurance to the people in the Philippines who are fascinated with bamboo and also very worried about their typhoons. So in this case, we made the compromise in a way that could bring the industry forward and bring the understanding and the appreciation of the material forward in what felt like a comfortable step for the developers of the project. In Panama, during COVID, without ever visiting the site, or still to this date not having been there, we were able to design a project that was built by a local team there, and they used local bamboo and local craftsmen, and we planned the kind of structural systems that would suit their skills. And we also incorporated timber that was pulled out of the Panama Canal that had been submerged for 100 years, which makes it very strong and also a beautiful material to use. So what we're doing, it's not entirely new. From little huts to elaborate bridges like this one in Java, photographed over 100 years ago, we know that bamboo has been in use across the tropical regions of the world for literally tens of thousands of years. There are islands and even continents that may have first been reached by bamboo rafts. But as you know, unprotected bamboo, it weathers, and untreated bamboo gets eaten to dust. So until recently, it was almost impossible to reliably protect the bamboo from insects. And just about everything that was ever built in those times is gone. And so fair enough that most people in Asia have thought that you just couldn't be poor enough or rural enough to actually want to live in a bamboo house. And part of what we've been thinking is just what will it take to change their minds, to convince people that bamboo is worth building with, much less worth aspiring to. And for us at Ibuku, our path has led us on the aspiration track more than the practical solution track. These houses are not the model of what people everywhere in the world should be living in, but they are artistic examples and imagination capturing proposals of how to catch people's hearts. Because if you design it properly and treat it carefully, a bamboo structure can last a lifetime. Just like a properly cared for wooden building could. And with increasing collaboration with innovation, the treatment solutions that we use and the protective coatings that we use will make it last even longer. So the key is that you have to build something extraordinary out of this material that people have been overlooking. Inspire people. What the resources that we had in Bali, in addition to an abundance of several types of very strong bamboo, is craftsmanship. Balinese culture values craftsmanship and cultivated artisans in many materials that we were able to combine with these adventurous outliers from new generations of locally trained architects and designers and engineers and bend them all together in a way that would allow us to create something new. But you always have to remember that you are designing for these curving, tapering, hollow poles, no two poles alike, no straight lines. These are not 2x4s. And sometimes I wish I was designing with 2x4s. And now sometimes I get to, because we're working with bamboo, not just in its pole form. The tried and true, well-crafted formulas and vocabulary of construction and architecture very often just do not apply here. We have often had to invent our own rules, question whether we were reinventing the wheel unnecessarily or actually diving in to consider a new way of doing things that might have value and use in that tiny spot of the universe or maybe in the wider world. But no matter what we do, we always have to first stand on the land where we're going to build and ask, how can we best belong there? And also we ask the bamboo what it's good at, what it wants to become. Before we spend too much time drawing, we talk to the craftsman. This cannot all happen on a flat paper or behind a flat screen. It's a conversation. So we design in real 3D, making scale structural models out of the same material that we'll later use to build the house. And bamboo model making, it is an art. It's also part of the engineering. These are not models to show a client. These are structural models from concept stage through to structural models that that guide the craftsmen. The craftsmen were not comfortable reading reams of paper. It made no sense. It makes no sense. And in the future, we won't be walking around with flat drawings in order to create three-dimensional structures. It won't even be part of the conversation anymore. And we've had to skip it and for practical purposes with the artisans anyway. And so we've built primarily from bamboo models and hand drawings in the early days. And now more and more we are supported by the digital in a very positive way. And we keep pulling back into analog as well and making sure that we're keeping ourselves grounded in reality while we venture forward. Even in terms of the industrial and machine world, this was the first time in 2021 was the first time we used heavy machinery on site. We needed to get those arches built very carefully on the ground, the artisans, and then lifted into place in a way that would keep the precision intact in order to achieve the very complex engineering of this building. So we let the machine bus when that makes sense. But when it comes down to the details, we really have to reconsider everything. In our world, there's nothing wrong with a right angle, except that it needs to prove its relevance just as much as any other shape. So we created these terraced steps toward this curved, this oval door in this curving house. These things all just connected. And why are doors so often rectangular? Well, there's lots of good reasons, and there's lots of practical considerations that have made that true. But when you have the chance to play and adventure and be outside of that convention, consider an artisan be really well served to be balanced on its center so that it can stay balanced over time. This is one of the very few places in the original artisanal bamboo houses that we made where we used any glue at all. There are no nails in the early houses. There is a staple gun that's used on the roof. There's a bit of glue in the laminate doors and big steel bolts in the primary structure. But there are very few other materials hidden away in the house. I wish I had just given up and used plywood. It would have saved us a lot of money and time and made things go much more smoothly in terms of communications and even with long-term maintenance in the early houses. But we didn't. We took the stand to work almost entirely and exclusively with bamboo, and we pushed the material really to its limit. But to reap the selective benefits and work within the constraints of a material, you have to push yourself. And within that constraint, we have really found spaces for something, and it's a challenge. But sometimes some challenges I just don't get into. My dad and my sister decided to make a treehouse. You know, sometimes kids and their parents do that. Well, this is my family's version. And at some point before the roof went on, my dad said, okay, now Ibuku should take it over and figure out how to make this roof in this branching tree. And I had honestly said, absolutely not. And he continued and persisted and made an incredible structure. And finally, when it was time for the interiors, I jumped in and got to play a bit in a safer way. And so when you have a big branching tree in the middle of a tree, why not keep going? Why not go up further? And if you're going to do so, get up there. How do you get up there in a way that feels like it belongs in relationship with that tree? Well, if it's bamboo, maybe it's bamboo duri, which curves. And then those curving elements winding their way up the tree, finding that on site with the craftsman. The drawings aren't barely relevant. This is a conversation. This is an interaction on site. And it's a joy. This room, it needed a ceiling. And flat ceilings, it takes a lot to make a flat ceiling special in my world. So in this one, we wove together. We stretched canvas over it, lacquered it. We tied together those little bits of bamboo with multicolored string. When we work in Bali with bamboo, we have these skilled craftsmen. It is mostly handmade. And in our first decade of building, we made everything out of these itsy bitsy little splits. And some of the structural connections even used bamboo pins. We use a lot of hand-wheel bamboo pins in a project. There are thousands of in each floor. And the feeling and texture you get out of this handmade and showing its natural properties floor is the texture. We've lost so much of the texture in the world, and letting bamboo's personality shine through the floor here gives us a sense of relationship to the world. Can this kind of conversation, can this kind of reconnection, can it affect the way that you walk through your day? Can it change the way that you live your life and the footprint that you're willing to ultimately leave on the world? We've made a really big footprint in the past 15 years. Thousands more bamboo buildings have been built around Bali, across Asia. We've influenced projects overseas. This is just a screen grab of bamboo in Bali. This is not just our work, although a lot of it shows up as that. We have trained craftsmen and created innovations that have spread like wildfire through this island, and the bamboo industry has been born here in just 15 years. People can be forgiven for looking on Airbnb and thinking that bamboo is a vernacular, curvy bamboo buildings are a vernacular traditional Balinese thing that they are encountering. And it is in a way, but only if it counts that it was done in the past 15 years by a team of local and international thinkers. And so we teach about bamboo too. Students come from around the world several times a year and do a 10-day course at Bamboo U. And the thing that I actually love to hear from them, some of them come and they want to build something out of bamboo, and we give them the tools and they learn lots of practical things related to it. What I love is when they say what they learned isn't just about bamboo, that they've learned how to apply this thinking to whatever they're doing in the world. And it's about having a conversation with the material. It's about remembering that you're part of nature and using it when you can in ways that still has its form and personality intact. And that's what we hold on to while we take on projects from clients who want a mixed media palette. Many of our clients, even seeing the bamboo houses that we've achieved, say, well, for them, maybe they want to mix in other materials. And there is this obvious bounty and beauty of bamboo that unleashes this sense of play and possibility and design. And there's this sense of goodness and future credibility connected with the bamboo that's a really important part of the conversation. And on a daily moment-to-moment level, the shapes that we create are intended to help us find comfort. And complementing it with other materials in a house can also help you achieve that practicality and comfort. We're looking for that right balance of connection and protection, to be enclosed while still being part of nature, and to find what material does what it can do best in that house. And it's difficult. When it comes down to it, nothing sustainably has compared to what we can do with bamboo. Every other material we're making is a compromise and is taking it down in that way. But we need to keep adventuring, and we need to keep trying how to connect with the world, how to have a conversation with people who think that they don't want this. And for the past 5 years, our homes have been consistently a mix of materials. This one only has bamboo in the roof. And on this one, the roofs, it's also mostly the roofs, but we are playing with lots of grid shells in the way that we did in the Arc, and working with terrazzo and teak and other design collaborators, in this case, Conchita Blanco, to make a incredible palette that is much more exciting, ultimately more exciting to a wider range of people to embrace bamboo in a way in their projects. And for overseas projects, people want us to achieve the kind of space that they have experienced we can make in Bali. And some of those places won't even let us use bamboo yet. This is a house in the woods outside of Atlanta, Georgia. It is mass timber arches, big, beautiful curving arches. Honestly, they are still figuring out how to get it built because of the way in which we pushed the limits and brought it into curving elements in a way that is not as familiar to the contractors there. but that this kind of structure, it really should be built out of bamboo. If this was built in 5 or 10 years, I truly hope that it could be made out of properly certified and competitively priced bamboo arches, because bamboo is actually better at this. And in some clients' projects, we aren't even using curves. We're paring it back and we're using all straight lines. And we're just an architecture studio working with all the other materials that you might work with, but still connecting nature and considering how do you bring a sense of place and a sense of context in. For every project, no matter where it is, we start with a conversation with all of the things that will come together on that site. This project's in Albania. It's a 60-room hotel. That'll be our biggest project. And our hearts, they are still in Bali, in bamboo. It is very hard to make something more beautiful than nature does. Back in 2010, when I completed this house, Sharma Springs, I was just beginning to grasp how far there is to go and how much there is left to learn. I am more aware of that than ever. And so when it comes down to it, what we ask ourselves often is, if we'd never seen a building before, if we'd never been in a house, what kind of shelter would we build if we remembered that we were part of nature? And if we insisted on only doing things toward the most beautiful, healthy future, we'd remember that being a little less bad is not enough, that we need goodness. And we need to do that with materials that will grow back in ways that we can keep doing forever. Thank you.
Yeah, so now, I'm completely inspired by bamboo, and I think we've all learned a whole lot. So to add to this conversation is a bit of a challenge, but what I was thinking about, like, why are we talking about bamboo to begin with? And it is, I think, because we know that we're facing, these very challenging statistics that the building industry that we're all involved in is contributing more carbon emissions than almost any other industry. And even if there's some new article that was published last week, even if every other industry stopped emitting carbon, that the building industry would continue and double our carbon emissions just by 2050. So bamboo is one of those incredible materials, and I think that's one of the reasons why we're all interested in this. Laura, like you said, to connect ourselves back to nature, to understand that by using this material, maybe we can come back. But so that's what I was struck by, like. And I think about, like, what's the appropriate use and region to use this material. We think about industrializing bamboo versus learning from the material or having a conversation with the material about beauty versus utility. So I know that was my kind of thought here. And I wonder if this is something that anybody Jonas, the way that you talked about industrializing bamboo versus Alora's use of the calm are very different ways to imagine a future for bamboo. And I wonder how you might react to what you just saw.
Yeah, so actually I've been to Green Village. It's a beautiful place, and for a few, and maybe as that idea spreads for some form of many in less urban places, it's an amazing opportunity, bamboo, in its natural form. But I would still say that, as we know, most humans are living in cities. Bamboo has another role to play, and it's not that we'll never see it expressed in a building, but I think its primary opportunity is in carbon sequestration and lightweight structure. So in other words, that the quality that it can build lightweight structures is like no other natural material, and I don't think we have to romanticize that to see its value.
I think if we can, the average consumer looking to build a house wants to know it's going to be durable, wants to have a competitive price in comparison with what else is offered in the market. And if you can prove that the performance of the building and the price are competitive with other materials, maybe there are some adventurous consumers that will be willing to use a new type of material like bamboo. But I think it is a lot to ask to also then ask that they completely change their aesthetic preference in the mass market. And so there's some of us that love like a rustic or eco-elegant, whimsical, however you want to describe it, type of aesthetic. And it's very beautiful and impressive. But in terms of like the, was it 96,000 houses per day that the population growth and underhoused population of the world calls for from us, from the building sector, it seems like those cost, performance, and design competitive solutions are what would help get bamboo into a higher percentage of that housing that's demanded. So I think that if we can, to some degree, actually, ironically, as much as I love the way bamboo looks, actually conceal it within the building so that it's both protected and then also can deliver a more common design aesthetic, that might, from my perspective, be our best chance at scaling it up.
Yeah, I mean, there seem to be two very different kind of lenses that looking at. One is a kind of pragmatic lens of, efficiency and kind of bringing things to market. The other is a level of almost seductive beauty that comes out of the material that's specific to the place. So, Laura, I was wondering if you could talk a little bit about, the way in which you're using bamboo seems to be absolutely specific to the climate that allows for that kind of exchange between inside and outside. And as you've been working in some of these colder climates with insulation and all these demands for enclosure, has it shifted how you've thought about how you use the bamboo? I mean, you've talked a little bit about moving to other materials, but I'm also curious, like, have you been able to modify bamboo to adapt to other climates, or is its real kind of quality specific to where it's grown?
As a designer, every project should be entirely based on the needs and the opportunities and hopes and dreams of where the project is. So there's absolutely no intention to say that anything that we've ever built here should be anywhere else in that way. It doesn't make sense. So in a new context, and all of that context must be considered, including local available industry and the cost considerations and the practicalities and the insulation. So when someone says, oh, well, that's all very nice in Bali, but how would you build it here? I said, well, you wouldn't. You'd build something else that works there, and it should look different and feel different. Well, it should feel exactly how you aspire for it to feel within the possibilities of the material and skills that you have in that place. So yes, no, don't take whole bamboo and go to a cold climate and try to build a house with a knife and a handsaw, which is what we can do here. Like involve many other tools and likely materials that you need to be able to achieve insulation. But as you do so, don't just end up at the hardware store buying the sheetrock. Like, consider like what materials are there and what ways of working with it could be if there was no artist. If you could just consider from as a thought exercise, as a design thought exercise, as a very necessary design thought exercise, is there a chance? Where do we have the chance to start fresh and not just continue in the ruts we're in industry? And at the same time, we need to make use of the efficiency of those well-trodden paths to replace things with bamboo because it's so much better in certain ways. So we need to do both. We need to use the momentum we have in certain areas to in a much better way. And often that's where bamboo can play in because of its natural characteristics. But also, where do we leap out and not be stuck on that path? This entire thing has felt like forging a new path through the jungle madness, right? So we need to do both.
it's interesting to hear the words about scaling. Like the reason to scale bamboo is because of all its incredible qualities. And we think about scale and industry, and that's a very 20th century concept. We know that the Industrial Revolution that felt like such a positive thing might not have been the greatest thing for our planet, for us here. And so I really appreciate the way that, Laura, you talk about, scaling this method of craftsmanship that's sensitive to the material itself. Or Jonas, you talked about industry not as mass industry, but micro industry. Like what can happen with a single motor and a group of really determined people. Or Lucas, the way that you talk about, growing more and more bamboo in a way that's sensitive to what it is. So I wonder if that new path forward has another way, like because we know that there have been challenges in scaling bamboo products, right? I mean, I think everyone, all three of you are probably aware of that they're curious about what those challenges have been when we try to treat bamboo like it's wood or like it's we want to not stay in the bamboo belt, for example, that you all showed, but instead say, oh, no, we should scale bamboo to send it around the world and build it everywhere and use it everywhere. So maybe you could describe what are the challenges to scaling bamboo in those industrial ways?
I'll take a crack at answering part of that. I mean, to me, it's actually scaling needs of these bamboo communities where they are. It's not like most of the efforts we've seen in the U.S. are to bring bamboo to the U.S. with the U.S. investment for the U.S. profit. But actually, I think if we were simply to actually export know-how, knowledge, inspiration, to the areas where bamboo grows and cross-pollinate in those locations with local knowledge, local values, that's where bamboo has the role to play. I mean, the good thing is that that's also where the demand is going to be in the next 30 years, right? So for me, I think we're going to ease into possibility. Yes, it takes more innovation. It takes a variety of examples. It takes more of what's going on in Bali. There are other places in the world it can go on too. It also takes, significant investment in lots of small startups. So these big companies like Bamcor, which Lucas will talk more about than I can, but they've made some amazing strides. But at the end of the day, they're competing with a 300-year-old timber industry. This is probably not going to, I don't think, at least in my professional life, I'm not sure if that's going to change and go well.
Yeah, at Bamcor, the bamboo panel, when I started working there, was basically a pine or conifer plywood core with vertically oriented bamboo slat sheets on either outside face. So it could be described as like a flattened I-beam. So it was a shear wall product, prefabricated with some technology developed in collaboration with AutoCAD that basically use a CNC machine with a router to cut the architectural details and into the panel, whether it's a power outlet, a window, door frame, and then with the other side of the CNC belt with a printer that printed on the details of the panel number, the nailing pattern, the electrical water lines indication, so that basically lowering the need for skilled carpenters at the job site and accelerating the framing process. We could frame a house in 4 hours, including putting in the trusses by just after lunch, have the roof sheathed also. I think, I forget the exact statistics of this, but like the truss industry, something like 30 years ago was like 75, 80% on-site fabrication of trusses. And now it's like flipped. Now it's like 80% plus prefabrication of all trusses that are then brought to the site. But in framing, it's still the other way around. It's still like 80, 90% on-site framing and very little prefabrication that happens. And so in almost every other industry, we've made really significant gains in efficiency in manufacturing, except for framing houses. And we have a major bottleneck in terms of available labor and scarcity or a shortage of housing in this country. And so it's a pretty major problem that we face as a society that impacts the cost of housing. And so that's really what ended up being the breakthrough technology in a way of Bamcor, more so than the innovative use of bamboo, because bamboo ended up being close to 3 times as expensive as a similarly performing eucalyptus pine combi panel that we ended up using towards the end of my time there. And so that panel, sourced from Brazil, where there's 6 million hectares of eucalyptus, another extremely fast-growing biogenic dense fiber, actually had a better carbon accounting story to it and had 85% of the performance at 30 or 40% of the cost of the bamboo panel. And so no one is ultimately willing, in the mass housing market at least, to pay a premium for a green product just because it's cool or feels good to do so. Maybe more so in a finishing product that you can see at the dinner party and point out to that, hey, check out my counter, it's made of bamboo, or check out my rocking chair, it's made of recycled wood or something like that. But what is actually concealed in your walls your house is made out of, no one even sees that. And so you just want to know as a consumer that it's durable and cost competitive, basically. And so anyways, that's the story of Bamcor. And like Jonas says, it wasn't for lack of trying or of smart people being involved or innovation that went into it. But I think there are some fundamental flaws with the idea of bringing a material to a context where arguably, from my perspective, it's not, and like Elora was saying too, might not be the best material for that context. And then there's also a history that could go a little further, not accusing Bamcor of this, but just companies in general tend to have wanted to extract materials from the global south and then look at ways of adding value and creating profit for our industrialized, developed economies and paying as little as possible for them in their origin and then maximizing profit for whoever the owners of those organizations are where they're being built. And so the fact that there's billions of houses needed to be built in the global south, but we can't somehow make profit and control it from the global north is apparently a turnoff to investors that something we shouldn't do. But from another perspective and another lens of value proposition is exactly what we should do. And that type of cross-pollination that is being achieved, I think, with Mass Boon, that Elora also talks to from the technology and design mixing with the craftsmanship of the amazing artisans in Bali is a good example of sort of rewriting that paradigm of the North-South collaboration.
So to that point, what is the future of Mass Boon? Like where do you move it forward from now? And is there a possibility of combining its kind of tectonic efficiency that's within the thickness of the walls with a more expressive approach to bamboo that Elora and the work that's coming out of Bali has? Are these incompatible, or can you find ways to hybridize these?
No, they're definitely not incompatible unless you want to meet fire code, right? So as soon as you want to meet fire code, then you probably can't leave lots of hollow combustible material fully exposed. So I think there'll be moments even in these multifamily housing units that we're going to develop where we're going to want to express the bamboo, want to have an honest use of material in some sense, just to acknowledge it. But I also think that if we take if we take the practicality of fire, take the practicality of acoustics, there are many reasons that only so much bamboo should be expressed, just like only so much wood should be expressed too. I mean, minerals, as challenging as they are, they're also what allow us to live, indoors, right? And I think that, Mass Boo has lots of challenges to overcome: fire, in-plane shear, really getting to this. My goal is to get to 90% efficiency, material efficiency. You could say that there's no waste with bamboo, that you get co-products. They're not waste, they're co-products. They can be used for energy or other bamboo products. But if you're going to get the value out of it, then you need the premium product. But that premium product is not just bamboo. It's bamboo and glue, or it's bamboo and minerals. And as much as I'd love to say, yeah, the long-term vision is to make these houses that are simply bamboo, I honestly don't think that the science will justify it.
I'm going to open it up to questions.
Wait, I want to answer the question. I want to one
okay,
about
you go for it.
scalability. Well, I'm really glad that you guys are working on the these really valuable practical steps and ways of working with bamboo because I've been pulled in a very different direction. And I am really interested in the scalability of the thinking and the ideas that I've learned through this wild journey. The scalability of how to just make people reconsider like what they're using. And it's, yeah, for me, it's not about like even encouraging anyone to work with bamboo in a curvy way that roots to its identity. It's about, we need to rethink the way that we're using all materials and which ones we use how, and then have them all work together with us to have a healthy world in the future.
I actually want to say one more thing too, just from as an educator, and I think frankly, if we're pioneering, we're all interested in educating in some way. And I think that the other role that bamboo plays in our context, in this very room or in my lab or in my classrooms is to back to the statement I made about eccentricity. Having students, having designers, having craftsmen be challenged with a material that is not ordinary, it's not regular.
Yes.
Right? That's something that we can learn a tremendous amount from. And it also kind of brings us a playful spirit that also kind of reignites our fascination with design and reminds us that most of the beauty that we're trying to unlock or uncover, it already exists. And it's our job to maybe do less, not more.
It's very clear that it has sparked that imagination in both of the projects in Bali or in this mass boo, that smushing it into a piece of plywood doesn't make as much sense in many ways. Yeah.
Hi, thank you so much. Fascinating talk. I'm working in the furniture space, and specifically, I'm looking to introduce and popularize some sustainably made, non-toxic, preferably bamboo furniture. And I'm aware of the adhesive problem and the glue problem in the composite material. And this applies in building spaces too, right? Especially with chemically sensitive people. They'll want to know, what kind of certification should I look for in the product that has the composite bamboo, or what specific qualities should I avoid? Like, how does someone know, looking at those composites, if they weren't marked already, what to look for that's less toxic or has less problematic chemicals in it? It's composite.
I think that's a question for you. No?
One baseline certification for interior uses for things is the CARB certification, the California Air Resource Board. But that's just like standard for any type of, something you're going to be sitting on and touching all the time or eating off of. You probably want to go steps further than that. It can, yeah, the adhesives, especially like a off-gassing analysis of the.
And I'll just add that there are some certifications we know, but they're not all. I mean, they're not all at a standard that we would. So Green Guard, for example, or Cradle to Cradle, for example, are certifications that might allow us to understand what is going to be more polluted in indoor air than we want it to be. But essentially, we do need to know what are the chemicals that are of mass, I'm using that word mass, concern, like formaldehyde, that are not regulated in this country, are allowed to be used, whether or not they're going to harm people or the planet, and that we have to stay away from. And so that's a kind of literacy that everybody needs to know in this country, because it's not regulated. In other countries, it is regulated. We don't have to worry about it so much in Norway, for example. But here, we need to know to avoid formaldehyde altogether. We could rely on certifications, but it's not enough. The regulations are not strong enough.
There's also the possibility that we just avoid gluing it, right? So there's a technology that is being more and more validated right now in the Philippines. It's been around in Latin America and in Asia for at least 20 or 30 years, probably longer, where you make bamboo into something, somewhat flat by splitting it. And then you basically laminate it with dowels called pinboo. So it won't give you a true solid, but the question is, how solid does something have to be solid-like? And I think that, instead of expecting bamboo to be wood and furniture to be made from solids like wood that are subtractive, maybe there's other ways to think about it. But it really takes rethinking, what is a table and what is a chair? What does it mean to sit, or what does it mean to work on a surface? And I think if we afford materials to meet us where they are, instead of expecting them to meet us where we are, then some of these questions are just fundamentally avoided.
There are resin innovations that are happening also, like soy-based and castor-based resins that are really promising, still not cost competitive, but I expect in the coming years, those will start to be more common.
Thank you so much for an amazing presentation and discussion so far. I saw in one of your slides that the bamboo belt includes the southern United States and Florida. So I just wanted to learn more and find out if we can actually grow bamboo in the United States, and if this is a promising industry, in the near or far future.
I've done like an inventory and assessment of the Florida plantations, and they're not growing the same way that you see in the tropics. Some people say it's the angle of the sun. Some people say the intensity of the lumen. Some people say maybe the genetics were sourced and they're sort of dwarf species. Maybe it's the beach sand type soil that all of Florida has with very little organic matter and growing in these like former really degraded citrus areas. I don't know exactly what it is, but I can say that a 5 or 6 year old Dendrocalamus asper plant in South Florida is like less than 20% the biomass of one in Ecuador or Philippines or Brazil. So not to say that it can't be done, and maybe that's just not the right species also, because I think it's the right species in the right place. And like a designer once told me, all bamboo is good for building. It's just you can be used in different ways. Even like tiny little bamboos, if you make packets of them, can be configured into columns or arches or different things. And so I know that in even like North Carolina and some places where it snows, there are some varieties of bamboo that they're having success with. So there's a company called National Bamboo, I think it is, that is doing some pretty cool work, experimenting on some significant scale plots, I think in North Carolina and Alabama.
There's also several women farmers that have been studying bamboo. One in Atlanta, one in Florida. I'm going to butcher their names. That's why I'm not trying to use them at this moment. And one from Massachusetts who's popularized bamboo, globally. And one of them told me, I don't remember which one it was, that the bamboo belt is moving north 30 miles per year. So again, like we have to think about what, how will climate change, how will bamboo have more opportunity because of climate change? That answer is still unknown.
The Florida Bamboo Growers Association is a good place to look to for information. There's a bunch of data they've done with the University of Florida, research they've done.
Which, I guess another point to make is that the United States is not just the continental United States, so Puerto Rico and Hawaii, and in some islands that are protected by the United States, there is bamboo. For example, the U.S. Forestry Station in Puerto Rico had something like 200 species of bamboo growing, now somewhat defunct, but there's certainly opportunities, on the edges of the United States that bamboo already has some roots, no pun intended.
Okay, thank you. Thank you guys for the presentation. Very informative. I have 2 questions. I just wanted to ask about, have you guys explored thermal ways of keeping it insulated? I know that you guys said, well, if it's in tropical climate, it's best to just leave it there. But what about like China? I know it gets cold over there in the northern side of China, and I'm pretty sure like the natives over there have houses that are built of bamboo, and maybe they use added materials to make it more insulated. Like over the years, wood, we started off with wood. We weren't satisfied with the thermal efficiency of wood, so we created more insulating properties to add it to make it more, warmer. So is there a possibility for bamboo in that area?
I mean, I guess the answer is perhaps, right? But I'm not sure how yet.
Are you asking if bamboo can be turned into a form of insulation, or are you wondering whether bamboo structures could have insulation? The latter will certainly. It's just a question of how you coordinate them. I think that the reason why I brought up that question was that the very geometries that we're seeing, the extraordinary geometries in Bali, are ones that actually are embraced in exchange between interior and exterior. So the question is, when you start building with bamboo, using it structurally and have to deal with enclosure, what consequences does that have on geometry that still might engage the very specifics of bamboo, but it would have to do it in a different way, right? So it's a super interesting question, and I think that's something that as we're looking for the possibilities of things beside concrete and steel for structure, and bamboo seems like an ideal yet potentially difficult product to bring to this country, if you will. One, would we even want to do that? And two, what would be the consequences, if of any, or would it simply be a substitution and disappearance of the wall section and we would never see it, right? So those are, I think, some of the questions that are outstanding, right? That still need to be addressed.
And Alora, you are working in places outside of Bali. Are you working in any of these conditions that do require more insulation? And how does your work in bamboo inform those decisions?
Well, we've worked a little bit more with keeping the cool air in and the heat out. But we haven't done a post and beam structure. We haven't done a round pole bamboo structure in a cold climate yet. And if I did, it would just be more about complementing what other materials would be good at creating the insulation. And maybe once innovated, bamboo sawdust would be a great insulator. But at this stage, I wouldn't dive into that. I'd be looking for complementary materials. And I would be designing the shape so that that was possible. They would have curves if the feeling of the people in it and the context of the landscape around it worked for curves. I just think the default to the rectangle is the problem, not rectangles themselves. In a city, it would very likely be rectangular to start with and then see where it evolves in the design process.
So I think we have time for one more question.
But it's definitely,
Thank you very much for the presentation, everybody. So my one question was, I know it's very difficult to use bamboo in cities, but if you could dream or you could give me an answer, what methods do you think you could recommend for bamboo growth and use being cost efficient and accessible in New York City while also dealing with building and fire code? Is there like a trick to it? That's my question.
I think that the products that Bamcor had are about as close as to a direct substitute for a building, code compliant building system that you could use in a city approved up to 6 stories. So cost competitiveness, desirability by the consumer base, those are other questions. But in terms of like performance, viability, I would say that would be your best option.
I'd also say that maybe bamboo is right for smaller cities as a structural material, at least in its round or semi-round form. But maybe the new cities, the growth should be with new cities that are built at a scale and with where you adapt the whole system to these new material realities, instead of asking bamboo to do what it can't, to do what wood can barely do in terms of fire performance. So if you said, what could bamboo do for New York? Probably inspire your imagination, probably be, used in a way that is more like an interior finish or non-structural surface. Those are places where I think bamboo has a role to play, a role to replace plastic and other materials that may have been used in the last 20 years to inspire kind of a creative, sensibility, kind of free form aesthetic. Well, the material by itself does that. So these are ways where bamboo could play a cultural role, but maybe not a structural one.
Or an example of Ethiopia, that the cities plan that they have.
Yeah, so I may get these numbers wrong, but there's something like 10,000 cities planned in Ethiopia, new cities that don't exist at all. And so if this is true, and maybe I have the number off by magnitude, so forgive me if I do, then, can these new cities grow in such a way that doesn't try to become a mega city? Maybe this is a more sustainable way to live. And maybe then suddenly the way that, that Allura is working has a place to play even within the city. And for sure, if Mass-Boo is successful, it will too, because we'll need multi-story structures that house lots of people.
Thank you.
So one of the fascinating things for me about bamboo is that it's not a new material at all, but it evolves in really interesting ways. And even looking at the work that you all have presented really has emerged in the last 10 years, right? So seeing where this goes, I think is going to be super fascinating. It's a material we have to find a way to kind of work with, given its unique capacities, its speed of growth, its relationship to carbon, et cetera. So I want to thank Allura, Lucas, and Jonah for your expertise, for your continued work on this. I do want to let you all know that there is continuing education credits available. There's some kind of code available, but I also want to thank Zoe and Damasi and Anne from the architecture lead for pulling this together. And thank you all for coming. Thank John Sara for being co-moderator. Thank you all.